Alright, today we'll talk on trigonometry. And the way I want you to look at trigonometry is the breakdown of those words. You have three, gono for side, metry for measure. So when we talk of trigonometry, we mean three-sided shape or polygon. The three-sided polygon we are talking about is triangles. So there are two kinds of triangles we'll be looking at. Basically three, but in two categories. The first category is the right angle triangle. A triangle like this. That's the right angle triangle. Then you can have an angle here or an angle here, whatever. So that's the right angle triangle. And then the other triangles we look at is the acute angle triangle. The acute angle triangle is drawn this way. And the obtuse angle triangle is this way. So when we'll be looking for the sides and the angles. So in trigonometry, we will be asked to find either the sides or the angles of the triangle. Now, in right angle triangle, when we are to find the sides, we make use of Pythagoras Theorem. And when we are to find the angle, we make use of the trigonometric ratios, SOHCAHTOA. So for right angle triangle, Pythagoras Theorem, trig ratio. So to find the sides in a right angle triangle, we make use of Pythagoras Theorem. And to find angles, you are given sides, you need to find angles, or you are given angle, you need to find sides. We make use of the trig ratios, which is SOHCAHTOA. I'll explain this in the course of the study. Now, for acute angle triangle and for obtuse angle triangle, we will make use of the sine rule and cosine rule. So when solving the sides and angles of either acute angle triangle or obtuse angle triangle, we make use of the sine rule or the cosine rule. The sine rule or the cosine rule, or you can use both of them in the lesson. So without further ado, I will go about showing you how to name the sides of a right angle triangle. The vertex, we have the vertex A, we have the vertex B, vertex C. These are for angles. And this B in mathematics, we write the side facing that B has the small letter B. The side facing that A has small letter A. The side facing C here has small letter C. So I'll show you how to name the sides of a right angle triangle. Now if you have a right angle triangle this way, and an angle is given here, that angle of reference. Now the line linking the 90 degree, this box 90 degree, the line linking 90 degree and this angle given, that line is called adjacent. Adjacent. Now, the side facing 90 degrees, this 90 degrees facing this side is called hypotenuse. Hypotenuse. Now the side facing the angle given is opposite. Opposite. I'll tell you again. The side linking the two angles, 90 degree and the acute angle, I said is adjacent. The side facing 90 degree box, this box, the 90 degree box, that's hypotenuse. Hypotenuse. And the side facing the angle is opposite. Very simple. Just remember, the angle faces here, opposite, 90 faces here, hypotenuse, then the last one here, adjacent. Alright, so we'll go back to Pythagoras Theorem. Pythagoras Theorem is used to find the side of a right angle triangle. Pythagoras Theorem says that the square on the hypotenuse If you square the hypotenuse, you square. If you square here, square here, square here, then you find out that the square of the hypotenuse is equal to the square of the other two sides when you add them, the sum of the squares on the other two sides. Meaning hypotenuse square is equal to opposite square plus adjacent square. Hypotenuse square, you square the hypotenuse, you square opposite, you square adjacent. If you add the squares of these together to give you the square of the hypotenuse. Now, if we come to the letter, that means b squared equals then a squared plus c squared. That's that. So always remember that. Now we have an example. A tree is 50 meters high. It casts a shadow of 8 meters on the ground. How far apart is the top of the tree from the top of the tree's shadow? A tree is 50 meters high. It casts a shadow of 8 meters on the ground. How far apart is the top of the tree from the top of the tree's shadow? So we start by sketching a tree. A tree is 50 meters high. Let's say this is the tree. So the tree is this. From here to here, that's 15 meters. That's the height. Now the shadow we have to fall this way. That's the shadow of the tree. Maybe the shadow of the tree is this way. And we are told the shadow is 8 meters. 8 meters on the ground. And that's, the ground is always horizontal. And that's why I'm putting it on the horizontal. Now you should complete this into a triangle, meaning you should have a line coming this way. Because that's what it's asking. That's the top of the tree here, and the top of the tree's shadow is here. So you have a right angle triangle like so. You have it this way. Right angle triangle where you have 15 meters, 8 meters here. So we have to find here. We have to find here. Maybe let's call this place H. So you observe that we can use Pythagoras Theorem because we are asked to find the sides, no angle is given. So we go ahead with Pythagoras Theorem that h squared equals 15 squared plus 8 squared. So h squared equals 225 plus 8 squared 64. Add them up. H squared equals, that's 289. Then you take square root. You need h, not h squared. So h is equal to square root of 289. And so h equals 17 meters. That means how far apart the top of the tree is actually 17 meters away from the top of the tree's shadow. And that's just one example. We'll look at one more example before we round up. Okay, in this we'll look at another example. It says in a triangle XYZ. Angle XYZ is 90 degrees. Side XZ is 13 centimeters. And side XY is 5 centimeters. Calculate the length of YZ. That means calculate the length of side YZ. Now the thing you should remember is that when you are given angle XYZ, it is the letter in the middle that should carry that angle. So angle Y is where we are going to put that 90 degrees. So we'll make a right angle triangle because of this 90 degrees. So I'll start with the right angle triangle. Then we should start by filling in this Y. Y, that's where that 90 degrees is. Then we can put this one as X here and here as Z. So that's that. Now let's fill in the details. XZ is 13 centimeters. So here is 13 centimeters. XY, 5 centimeters. XY, 5 centimeters. Then we are told to find YZ. So with your Pythagoras theorem, you can go that, okay, XZ squared equals XY squared plus YZ squared. So that's that. And we need to look for YZ. So what do? We can bring this one over here, or we start by filling in the details. 13 squared equals 5 squared plus YZ squared. So we move this one here first so that this can stand alone. We have 13 squared minus 5 squared equals side YZ squared. Now we have 169 minus 25 equals side YZ
square.
And 169 minus 25
To give you 144, which is what? YZ square.
Now you can take square root of both sides.
So square root of 144 will give you YZ. And square root of 144 is 12 centimeter equals side YZ. Or therefore, YZ, and turn it around, YZ equals 12 centimeters.
So YZ is 12 centimeters. Okay, thank you.